just going to get them the website as we go. What the board conversions will be. All right. May I? Great. Do you have a horizon there? Oh no, I can't see them. I don't see it. No, I think we should wait 1 or 2 minutes to see the people. It's the break, so we have some spare time. Yeah. Cameras. We were giving a couple minutes to Deborah, but we're going to start. Shall we? Yeah. Hello, everyone. This is the Past Competition Element Working Group meeting. So you should be familiar with the note well. This is an updated version, so it's new for brand new for this week. Please be aware that there is this new RFC 8179, which mentions some new rules and policy. So make sure you're aware of the new content and that you abide by the rules. You may also be familiar with the usual common session with the MPLS and CCamp session about Young, on which happening on Thursday this time. Also Tears, I forgot to mention Tears. Tears is in charge of the slot, but this is a common slot to discuss cross working group about the young models that could benefit from coordination there. So from the administrative perspective, you are also aware of the usual blue sheets. Please make sure you sign them down. We need to identify how many people are in the room to be allocated the right size for the rooms over the IETF meetings. Sometimes we don't have the same level of room size in IETF hotels, so make sure your seat will be available next time. For people who will come at the mic, if you're going to present, please make sure you are inside the pink square on the floor. We're also broadcasted also on the audio, so even if you aren't presenting, if you want to make a comment, raise a question, or anything related to the presentation progress, please make sure you correctly use the mics in the room. Don't forget to state your name. People who are attending remote too at this stage, maybe more later, will appreciate that you state your name before you start your comment. Want to add?
So I just wanted to check we have some volunteers to help with the minutes. Drew is helping remotely, but locally, Dan, you volunteered. So we're going to be taking the minutes in the Etherpad. If you want to stay involved in the working group, please head on over to the Etherpad as we're presenting. You can write down what's happening in the working group and help us all keep the minutes up to date. Thank you.
Still about Dan and Drew. So you may be aware that Dan has stepped down as a secretary, but he remains involved, as you see. He's doing minutes today too. So thank you for your secretary role, Dan, and thank you for all the upcoming work. It has been and will still a pleasure to work with you. So. And Drew, who most of you should know, has agreed to become the new Past Competition Element Working Group Secretary. So unfortunately, he can't be there this time, but as you see, he's connected. He'll be trying to present remotely later. So thank you, Drew, for agreeing to be the new secretary. We appreciate your effort for the PCE Working Group now and in the future. A few reminders about the mailing list. We still feel that the mailing list is purely used to address comments, resolve issues, raise pinpoints or anything. So please be aware that the list is necessary to track the work in progress, to judge the consensus on some item, to be aware of the support on hot topics. So even if you consider that your work is progressing, remind your co-author that many things should be shared on the list to make the working group aware of your work in progress, and make sure that everyone is aware of what's happening on drafts, on everything related to the work in progress. We may, depending on the agenda we have, use that criteria also to allocate slots. So make sure that you don't fall into the wrong category. We have this time slightly light agenda because we're allocated more time than we had requested. So we hope that we won't consume the full 2-hour slot, but in case we have some spare time, so don't think we need to bash anything unless someone wants to. So we can move on. About our internet drafts. So we don't have any new RFC since Chicago meeting, but in the background, it's been progressing a lot. We have not less than 4 drafts in the RFC editor's queue with combined dependencies to each other. So we hope to resolve that package pretty soon. We also have 3 IDs with the IESG. So Deborah told us that one of them is scheduled in the IETF chat on August 3, which happened to be my son's birthday. And we also have some other drafts who are ready to move forward soon. Also, still with the working group, we have a draft which is waiting for an update after the latest review. I think Dan was the editor. So for the matter of the process, we need to have an up-to-date draft to move forward.
Hi, Daniel King. Yes, so I kind of feel a sense of deja vu here because I think I was planning to submit a new version after the last IETF, but things just got a little bit busy. So for, a mea culpa, sorry. We have a new version. I need to review it with one of the implementers. That person happens to be Dhruv, who is not here this week. We have already spoken and we are planning to catch up next week after the IETF. So we'll review that and then submit target end of next week.
Okay, great. Thank you for the feedback. We have some other drafts which are ready for Shepherd review. One of them is waiting for the others, so I hope that summertime will be the right time to share the reviews of some of them. One of them has been identified with an action item during working group last call. So it needs that the LSP setup type needs an update before moving to the Shepherd review, but it's a matter of process time mainly. I think the authors came into an agreement on that. You want to come on that, John?
Yeah, to comment on LSP setup type, it's a co-author, and the remaining issue came down to wanting to be explicit about whether a PCC supports setup by RSVP or not, and we're considering either making a non-backwards compatible change to the draft or doing something else which is kind of suboptimal protocol-wise. So really we need to check with the implementers about deployments and whether we can make that change, and that's what's the delay. But after we solve that, then it's good to go. We're hoping to get that solved very soon.
Okay, so we can expect maybe an email with to the list soon to judge.
Next step is an email to the list, I think, just to close down the issue, which there's nothing blocking that other than my foreground time.
Okay. And we also have a queue for working group last call. One of the ID there is pending the previous one, which just mentioned. And the other one is pending a refresh because it's expired. So before starting working group last call, we would need a version which is still valid. We also have a bunch of drafts which aren't on the agenda for today. Two of them are related to ACTN work, which is in progress also in TEAS. For both, there has been some new text added there, some editorial change, so they are moving forward with some work in progress there. We also have a PCEP Young module, which has been updated to be compliant to NMDA, has many of the routing area Young modules these days. So at least the PCEP Young module is catching up with the new requirements on that. TLS has been considered. The associated RFC for PCEP is in the editor queue, I guess, or no, with Deborah. So it's becoming consistent with what we have in the PCEP toolset. There is an open issue that maybe Dhruv wants to comment about the notification there. Maybe that could be a global question that spans beyond PCEP itself. So I don't know if Dhruv can add something there.
Hi. So I mailed a question to the Yang doctors as well, asking what is the guideline with respect to should the models have notifications or rely only on the Yang push mechanism. I have not yet get a feedback. I will try to ask one of my co-authors to catch the Yang doctors this week and try to get this resolved.
So other things not on the agenda for today, the stateful PCE auto bandwidth has recently been updated, addressing some outstanding review comments, a few editorial changes, adding default values for parameters. And the authors are at this time, I believe, requesting the working group last call. So I think this draft seems to have been stable for quite a while. And if it remains so, then we'll happily issue the last call. But please, if you haven't reviewed this yet, then do so and send your comments and suggestions to the list. Stateful PCE with points and multi-points has been updated recently to align with the RC 6006 BIS draft and the changes to the stateful PCE that were made prior to its sort of preparation for the RC editor. And again, unless there are significant comments on the list, and we'll be moving back to working group last call reasonably soon. So other drafts, the experimental code points draft, there have been minor updates that the authors haven't received much feedback, and they think that it's going to be ready for working group last call. So this one, I think this is a high priority for us. We've had issues with code points in the recent past, and I think this draft will help going forward the process for sorting those out. So we are going to push that forward as hard and as soon as we can. So if anyone thinks they're going to have anything else to say about it, then please do so in the short term before we move it on and request publication. The association diversity draft has been presented. The last IETF, not this time, no change, seems stable. Again, association policy was recently updated, no request to present this time. Same for stateful PCE GMPLS. And we've recently adopted the LSP scheduling draft following the architecture work in T's as a new working group doc. Various documents are expired. Some of them I think just need to keep alive, like Dan has already addressed the inter-area AS applicability. The GMPLS piece of extensions I think is probably waiting for the Shepherd before the next version is submitted. The WS on RWA I think is in the same position. It needs to be issued with a keep alive, but is waiting for the GMPLS piece of extensions to get shepherded. And hierarchy extensions, we're ready to do the working group last call on that. It just needs the update to be done. End of the week. Dan says end of the week. And I'm happy. Thank you, Dan. A couple of documents we think are orphaned now. So the PCE remote initiated GMPLS LSP is expired a long time now, and we haven't heard from any of the authors in a long time. So is there still an editor in charge of this? If so, please let me know now or let us know offline. If not, then this may have no future. And the other one is the PCE enhanced errors, which died and then was reborn a few IETFs ago with a new editor, Jen, but Jen has moved on again. So once again, this document is treading water. If anyone wants to pick this up, then please let us know. Otherwise, again, this one won't have a future. So that's the working group status. Any comments or questions?
I'm preparing.
Great. So okay, so we'll move to the first presentation. Okay, Dhruv, I guess you have to shout at me to move the slides on. Is that right?
Yeah, I'll do that.
Okay.
So this is the association draft, and the base association draft has been a working group document for a while. It's just that I have joined as an editor recently, based on the various comments that bunch of us who had other association types documents wanted the base draft to handle. So after discussing with the existing authors, we have made this update. Next slide, please. So a quick introduction. This is basically a generic mechanism to group set of LSPs in the context of PSEP. And what we do is you can group set of LSPs as well as set of attributes or policies. So that's why we have the policy association draft and diversity draft, etc. What this draft does is it creates a generic association object, and that object can be carried in various PSEP messages like update, report, initiate, and request. It is the job of other documents to actually go ahead and create new association types. And we have two working group documents, diversity and policy, and bunch of individual documents like protection, bidirection, MBB, and something which is on agenda today for multi-layer as well. Next slide. So what we did in this document, the major update was that we kind of described dynamic associations and operator configured association explicitly in the base draft. This is something that was happening. Why? Because policy, let's take policy as an example, in which case the policies was pre-configured. So that was an operator configured association. And then there are some association like protection, where you just enable protection for a particular tunnel, and then you have bunch of LSPs which are dynamically belonging to an association type protection. So these two different associations were already existing within PSEP, but we did not talk about it in the base association draft. So what we did this time is explicitly say that there are two types of association, some associations which are dynamically created by PSEP peers, and some which will be configured by the operator, and clearly set it out that what is the mechanism to do both, what will be the differences in each of them. So just to compare the two, in case of dynamic association, basically the associations are created dynamically. We use PSEP protocol mechanism to notify the peer that is this is an association, and these are the bunch of LSPs that belong to a particular association. And the association identifiers, those are picked dynamically by the PSEP speaker, and the association is associated with the LSP state. So till the LSP exists, association information also exists. In case of operator configured association, what happens is that the association information needs to be manually configured by the operator. He should configure the association ID, the type, the source, all this information. And then we can use PSEP as a mechanism to notify which LSPs needs to join which association, which are pre-configured on the PSEP peer. And these associations need to be manually removed, since operator is the one which has configured it. But dynamically, LSPs can join or disjoin this existing operator configured association. Next slide. So this leads to a problem only for association types which may have both operator configured as well as dynamic. We need to worry about the association ID, range of association ID, so that there is no clash between a dynamic association that is picked by a peer dynamically and then some associations which are configured by the operator. So to solve this, we propose to have a operator configured association range for each association type, and then communicate this to the peer, so that when a dynamic association ID is picked, there is no conflict. And this is basically carried in an open message, and you can see the TLV format on the right hand side. This needs to be done only for association types that will have both dynamic and operator configured associations. For example, if you are protection, then you don't need to worry about it. All your associations are always dynamic. So the full range of association ID can be used by dynamic itself. This needs to be done only for association types that could be both, and this is being clarified in the document. Next slide. One thing also we did was we kind of added new error codes in the base association drafts. We were seeing that some new association types were adding error codes which are quite generic and are applicable for any association type. So we kind of moved them to the base draft. So these are some of the generic errors. Errors like association type is not supported, or there are too many LSPs which have joined an association group, making it unmanageable. To avoid any issues, sometimes the number of association groups itself is too many. In case the association should be configured before or known before, the association itself is unknown. There is a mismatch of information between what is locally configured and what the peer is reporting. You may remember that this was something that was written in the diversity draft. So we considered that this needs to be in the base draft itself. So we have moved these error codes here. And then also association information mismatch between the past information and the latest information. Next slide. We also clarified some of the processing rules, especially with respect to what should happen when the session goes down, what is the time that the association information should be cleared. Since the associations are a properties of an LSP, we linked it to the LSP state itself. So similar to the handling of LSP state, which is based on the state timeout interval value, the same procedure is used for association information as well. And some associations, and if the state timeout interval is infinity, that means when the LSP state is kept forever, in that case, associations will also be kept forever. We also clarified what should happen at the time of redelegation. So if you have redelegated a LSP to a new PC, the old association is still valid until the new PCs explicitly removes that association. So we kind of cleared all those behaviors and updated the processing rules for base association. Next slide. Just a summary. What are the updates? The updates have dynamic and operator configured association explicitly spelled out. To handle the case of ID range conflict, we added operator configured association range handling. There were some restrictions in the base draft earlier. For example, the base draft said that it's only a PCE that can add associations with LSPs that are not from the same head node. We removed it because if you see the diversity use case, there is a use case for having an association there as well, which is explained in the diversity draft. We also had some restriction on who could be the association source, what should be the IP address that should be used in association source. So we removed this restriction so that in case of a multiple PCE or multiple PCs acting as a backup to each other, a common virtual IP or other IPs could be used as an association source rather than a strict PCE IP address, which could be useful. We added errors, which you have seen, and also updated the manageability and security consideration section about these drafts. Next slide. So this is the note to other association drafts authors. This we have discussed with them offline as well. What needs to be done here is that each association draft which defines a new association type should explicitly state whether this particular type is dynamic, operator configured, or both. And in case of both, clearly set out what is the range they would like to keep aside for operator configured association. Note that this is a configurable parameters, but we would like these authors to state what should be the default value if things are not set. Next slide. So this has been already discussed with the association draft authors. We also got comments from Stefan, Rakesh, Mustafa. All of this has been incorporated. Now at this stage, we would like more eyes from the working group and see whether what we have done is okay. And try to, since this implementation exists for association, we would also want to make sure that we get INA early allocation and think about moving this to last call, as multiple association documents depend on this. Thank you.
Drew, this is John Hardwick. And just a technical question on this draft. So if you have a dynamic association group, is the association group ID taken from the available space on the head-end PCC?
Yes.
And what about the case where you have an association between two LSPs which do not have the same head-end PCC?
So usually in those cases, the association source is usually the PC ID or a generic ID. It's never the PCC's IP address. So what happens is, since associations are identified by association ID, association type, and the association source, so together they act as a key. In those cases, usually in a multi-head case, it's usually the stateful PC IP address is the one that we use as a source, or a generic IP address like 000. Or so that's the thing where we remove the restriction on having the PC IP address or a PCC IP address as the association source. So via this mechanism, things can be taken care.
So in that case, this association group ID is not taken out of the head-end PCC's number space, it's taken out of the PCE's number space.
Usually, yes, yeah.
Okay.
But the main aim
it just seems...
the main aim is just let me clarify this a little bit. So the main aim is, if I am a PCEP implementation and I have to pick a dynamic association, operator configured association might be set up at any time. So we want to just make sure that the dynamic association, and usually the person who picks the dynamic association is usually the association source most of the time. So he is making sure that I am not going to pick an association ID that might be configured later or is being configured on another peer, leading to clash and rollback and all those mechanisms. So the clear idea was, let the dynamic associations be have a different range, and the operator configured one have a different range. So there's no clash.
I'm curious why we didn't make those ranges explicit in the through IANA or something like that, rather than having to have this sort of complicated per association type, per PCC configured range. It would seem simpler just to say, the first half of a space is operator configured, the next half of the space is dynamic. Why do we need the extra complexity?
Yeah, this is exactly what my first, the first draft that I prepared, I tried to do. But I got feedback from various association authors who were saying that, we only have, most of us are only using dynamic or only using operator configured. These are limited sets of associations where we have both. So if we have to sacrifice the association identifier space, if we have a fixed value, that was something that was not acceptable to some of the authors. So to allow that, we said, let us have this range, and let the default value be specified by each association type. So only if the operator is manually changing the value, then you need to carry these TLVs. Otherwise, the default values and this will suffice. But let it be per association type rather than a generic value.
This is Rakesh Gandhi from Cisco. Yes, so association ID range is, the context is the association source and association type. So irrespective of if it's the same head-end or different head-ends, that's the context. So you have to allocate association ID or range, uniquely on two sides if you need to be, or at the PCE. But the context is, as Drew was saying, that association source, type, and ID are the keys. So it has to be unique. And the second comment is that for bidirectional LSPs, we do have two head-ends who can initiate the LSPs, and we need to associate. The bidirectional LSPs, we don't have dynamic association thing. It's really the operator configured. So we didn't want to have this kind of restrictions where some IDs you cannot use. It's only for only for dynamic, right? So we wanted to have the whole range. So this is one reason why we have it the way it is.
Okay, yeah, I get both of those points. I guess it just seems quite complex for what seems like a fairly simple problem.
Okay, thanks.
So we need to move on. The next presenter is Daniele. Thank you, Dwarf.
Hello. What I'm going to present you, it's a kind of experiment, but it's the wrong presentation.
Yeah, no, that's not the wrong one.
No.
That's the one. Yes.
This is the one. I realized it. Incredible. Thank you. So, introduction. The proposal here is to add two metrics to PSAP. The first one is the unreserved bandwidth of a path, of an entire path at a given priority. Basically, what it is, it's the minimum value of the unreserved bandwidth at a given priority among all the links of a given path. The other one is the path residual bandwidth. It's exactly the same thing, but it's referring to the physical available bandwidth along that path. Why the proposal to add these two new metrics? There are three main reasons. The first one is that when metrics are returned as a result of the path computation, they can be used to know how much traffic can still be routed over that path. There is an example coming on which explains a use case in which this is extremely interesting. The second being optimizing a path against a reserved or residual bandwidth allows a better usage of the network resources. So basically, pure optimization. The third one, putting constraints on the value of a reserved residual bandwidth helps preventing bottlenecks, obviously. Background. So there is something similar in RFC 5541. There is an objective function called MBP, maximum residual bandwidth path. This is something that allows you to compute path maximizing the minimum value of the residual bandwidth, which is more or less what we are looking for. It, as a result, it returns the largest bottleneck in the network. But what's the problem? The problem is that this one is not exactly what we need, and it's an objective function, not a metric. This means that this is a parameter that cannot be returned as a result of path computation. Then only the physically available bandwidth is taken into account, while we said that we would like to have not just the physical bandwidth, but also the unreserved bandwidth at given priorities. And it is not possible to put constraints on the bottleneck of the path. What is the use case? Hierarchical SDN or hierarchical path computation. Basically, the use case we started from when thinking of this extension is a hierarchical PCE in an ICTN scenario where black topology is used. I'm the hierarchical PCE. I need to compute a path between one node in the first domain and another node in the last domain. I have to ask all the different PCEs for a path computation in their domain. Okay, I need to allocate other traffic with the same characteristics. I have to iterate this process again and again and again. What if I can collect the amount of bandwidth that is still available in my first request? I can save a huge number of requests. So we said, okay, let's try to see if this makes sense. We built a simulator. It's a simulator that simulates a Manhattan-like network domain, where all the domains are black, meaning that just the border nodes are presented to the hierarchical PCE. It allows for setting up and tear down LSPs. It simulates LSP removals, and so on and so forth. And so we did some simulations, which are cut. And okay, no worries. So these are the results of a simulation in which we have network domains, 10 by 10 nodes in a Manhattan-like scenario. And we did the simulation with 3 by 3 network domains and 4 by 4. 1,000 paths. You can find all the details there. What's interesting, we did this simulation with the 3 different scenarios. The first one, there is no caching. Basically, we allocate 10,000 paths. At every time, we ask all the child PCE if it is possible to compute a path. Those are the results. So in the case of 3 by 3 network domains, we have 13,000 requests, mean time 3 seconds and a half, and 8 seconds as a maximum time. 4 by 4, you see the numbers over there, is 35,000 and so on. Then we did a second simulation in which we did caching of the result of the previous path computation. In this case, I'll try to explain again what does it mean. It means that we ask for a path between A and B. The path most likely will be, I don't know, 10 gigabit path, 100 gigabit path. We just need a few megs. The second request needs a few megs between those endpoints, and we go on. The second scenario is caching without residual bandwidth. So we just keep the computed path, and we try to reuse it. We might succeed, we might fail. In case we fail, we do the path computation again. The third one is even better because we keep track of the path that we asked for the first time, and we keep track of the bandwidth that is still available in that path. In that case, suppose we have a scenario like this one, where the bottleneck is at 20 giga, and we make a 1 gigabit request. For 20 times, we know for sure that we will succeed in the activation without the need for another path computation. And we already know that the 21st request will fail. So in that case, without waiting for the crankback, we will directly ask for a new path computation. So again, what are the changes to the protocol that we are proposing? First one, path unreserved bandwidth at a given priority k. Suppose you have this link, the value would be 20 gigabits. This path, sorry, not link. Then the path residual bandwidth, in this case, would be 10 gigabit over those two links, which is associated to the end-to-end path. The encoding is super simple. It's just C32 bits added to the metric object defined in RFC 5440. And that's it. So basically, these are the numbers. We thought that with these numbers, it could be worth trying to propose this kind of extension. You see that in the 3 by 3 domain, we go down from 13,000 requests to 3,600. So that's the reason for proposing the draft. Next steps. So it's a simple extension. There is absolutely no dependency. Proven improvements. Those are the numbers. Now the question, is there any interest in the working group to implemented these extensions.
Any feedback from the room or from remote attendees?
John Hardwick, I've got a question just to clarify, Daniele. So the applicability of this, if I understand that, is cases where there's really only one source which is requesting the LSP. Because you need to be able to rely on the residual bandwidth that is returned, not changing through some other source that's gobbling bandwidth.
One source meaning a single hierarchical PCE,
Yeah.
and not many.
Or indeed, in a non-hierarchical case, you can have multiple PCCs setting up LSPs through the network. So in that case, the bandwidth available is going to change after the computation reply. So I guess I'm asking, how broadly applicable is this? Is this like a really narrow thing for ACTN, or is it like?
Actually, we didn't think of multiple sources. Probably. Once the information is propagated from the child PCE to the hierarchical PCE, if there are other hierarchical PCEs, that hierarchical PCE needs to propagate the information to the others. This could be a solution, but the idea was a single source.
Okay, thanks.
Let's see if we have a question for Drev. Daniele, if you can stay there for one more minute, please.
Hi, Daniele. So I think what John asked was like first part of my question. That is, I think in this case, this will only work, even if we are having about a single source, this will only work if after I have made a request and I've got the residual bandwidth, I know that nobody else is making a request. Because even if somebody else makes a request and uses up more bandwidth, I would not know. But I wanted to understand that in your case, you were saying that you know that for 20 more requests things are available, but at 21st I should do path computation. So if in this proposal we have a mechanism to figure it out, that what is the time which we know that the bandwidth is over. Basically, that's what you want to do. The thing is doing it via a reply mechanism, which is at max the state at this moment of time, and with no guarantee that this is going to continue, because this is at the proposal is still stateless here. So I am a little confused by that. I will give you an example. We do delay like this, right? You compute a path, you get end-to-end delay, but that should be only used at the time of path computation, and then we need to rely on telemetry or some other mechanism to know what is the actual delay later on, not the delay that I had at the time of path computation. So I am trying to apply the same logic here and seeing whether what we are doing here is right or not.
Well, actually, if in that case, if you're lucky, you save iterations between the hierarchical PCE and the child PCE. In the worst case, you don't get anything worse than without these extensions.
That I can
okay.
Thank you. If you want to go deeper, please use the list. It's there for that purpose. Next presenter is Yang for the flexible grid extension.
Good afternoon. This is Yang Lee. I think I'm going to present PCEP extension for flex grid networks. We have many multi-vendor authors and research who implemented this feature already. I think I see PCEP extension for flex grid as early as 2009, and obviously that was too early. And but now, why we are presenting now? Because of maturity of PCEP flex grid framework in CCAMP. RFC 7698 has been published for a while, and then OSPFT and RSPPT also is very close to maturity. I think some of them has become RFC, I guess, and RFCQ. So it's the right time. And also we have deployment of this technology into commercial networks. So what are the flex grid networks? I think we are familiar with fixed grid, which is known as WSAN, wavelength switched optical networks, but it deals with lambda bandwidth is fixed. If it is 10 gig system, it's a 10 gig system. But here we are talking about flexible grid. I think ITUT G.694.1 and G.872, they define a new DWDM grid, which is called flex grid, by defining a set of nominal central frequency and then channel spacing, and they bring the concept of frequency slot. So I don't want to get into detail about this technology, but some of you may not be familiar with this technology, so I just want to give some flex grid example. So basically, for the flex grid, DWDM grid, the allowed frequency slot has a nominal frequency, central frequency in terahertz, defined by that number over there, 193.1 plus n times 0.00625, where n is positive or negative integer with respect to 0. And that 0.00625 is the nominal central frequency granularity. And the slot width is defined by another parameter, 12.5 times m, where m is a positive integer and 12.5 is a slot with granularity. So if you look at the anchor frequency 193.1 on the circle on the bottom, and you can have m equal 4, then you have -4 and +4, so it occupies 50 gigahertz slot width. So you can have a flexible slot width if m number increases. So that's the basic idea of flex grid networks. So in PSAP context, we basically add one object called spectrum assignment object, along with RPN endpoints and other optional objects. And then we define several TLVs under that the spectrum assignment object. So this is how a spectrum assignment object looks like. We have a 2 TLV defined, frequency slot selection TLV and frequency slot restriction constraint TLV. And then the corner on the M indicate mode, which is explicit label control, ELC mode. We are debating whether we should support label set distributed hop by hop. We are at this moment proposing only ELC, means PC just assigns exact frequency slot to be used at each hop, instead of each node kind of decided from the set the PC recommends, because that has some RSVP implications, so we don't want to depend on something that is not available at this moment. And the frequency slot selection TLB looks like that. This is basically how to select a frequency slot. If you know RWA assignment, as a lambda assignment, there's a way to assign lambda. So it basically suggests to PC see how to select a frequency slot based on n parameter. So we have first fit or random or other method. This is try to avoid the fragmentation of the slot assignment on the fiber. And then the frequency slot restriction constraints is basically kind of giving some tunable range, because it may not be all tunable for all spectrum. So it gives some frequency slot restriction field for each link identifier. So it's a kind of recursive. We may have multiple links and multiple restriction in one shot. So we are using actually what OSPF developed on the frequency slot restriction field. And then frequency slot allocation is basically reply to the request. So some open issue is for action field in terms of label set. We only propose to support bitmap encoding. We're not, I think which is very consistent with FlexGrid Yang work as well, that is taking place in parallel. And yeah, the need for frequency slot allocation, TLB is subject to further determination, but we specify in the current draft. And there may be some other issues, but just wanted to propose that this might be a right fit in the right time. So any interest party, I think is welcome to join, co-working with us.
Any question from the room? No, I have one actually. About the frequency slot restriction, why don't you consider reusing the generic label set mechanism to express this restriction?
Actually, we do, but we only support bitmap out of so many actions. There are 4 or 5 actions.
You don't reuse the generic mechanism. You use the idea with a specific encoding.
Right.
So
the generic mechanism.
Yeah, there is a more generic that is more technology agnostic that could be reused to achieve that same purpose. So why do you specify a new TLD there while you could achieve the same as any other technology?
Oh, that's good. We have a more field because you have to. You have N and M field. You have to specify both. Mm-hmm. So so existing mechanism has only one label, right?
No, the label in WDM allows you to, in FlexiGrid allows you to specify N and M.
Yes.
So it's a specific set of label that you use as constraints, but I feel that the label set fits there.
It is exactly, that's what we are proposing. Maybe we are using exactly label set encoding, but out of many actions, we choose only one, bitmap mapping. That's what I'm saying.
Yeah, maybe I should read again then.
Okay.
But,
right.
It's not obvious when I read the draft.
Right. Okay.
By the way, you say continue to mature the graph. I agree with that. I saw also in the draft that you are mentioning some pass error messages with routing problem error codes. We don't have pass error in PSEP. It's RSVP message.
That's right. Yeah,
so
we'll clean up a little bit. Yeah.
Agree with the last bullet.
Yes. Okay. Thank you.
Thank you, Yang. Next presenter is Fang Wei.
So my name is Fang Wei from ZT. So my topic is about PCE multi-level LSP association. So next. Okay, so this is the 0 version draft, and this is the first time to present in this meeting. So the document proposes a set of extension to PCP to associate a group of multi-level LSP. So this multi-level LSP include one upper layer LSP and one or several lower layer LSPs. So we have 2 use cases for the multi-level LSP association. The first is used for the bandwidth adjustment. So the set for PCE provides the ability to adjust the bandwidth. For example, we want to enlarge the upper layer LSP. So if we use the associate group, we can adjust the upper layer LSP and the lower layer LSP at the same time. So this is the first use case, and the second use case is that for the T-link optimization. For example, if some of the lower layer LSP is failed, So we can use the associate type RSP to optimize the up nail RSP. So this is the second use case for our multi-layer RSP association. So this is the association type. So there is a optional association object type to carry both in the IPv4 and the IPv6. So for the association type, we can say that it can be dynamic or operation configured. So for the range, I think we can discuss later. So this is the nail associated TLV. So the TLV is very simple. We define a flag to indicate the upper nail RSP or the lower RSP. Yeah, so this is the extension operation. So we think that our multi-nail RSP is the same operator with the associate group. The associate object will be carried in the request state report and update and initial message. So once a group of multi-level RSP is created, the upper layer RSP is associated with its related lower layer RSP. So this is my presentation for this draft. So next step is to discuss with the associate draft authors, with the other authors, and comments. Okay.
Any comments from the room? I'm sort of interested to get a show of hands. Who has read this document? Okay, so I think I saw 3 hands not confidently raised. I think we need to see a little bit more engagement with the working group before we can really pull for adoption on this.
Okay, thank you.
Young, are you going to present the next one?
This is Young again. This time I'd like to present PCEP extension for stitching LSP in hierarchical stateful PC environment. Basically this is the high-level stateful HPC environment. As you see here, we have multi-domain, and then we have domain LSP, and there are multiple of them, but we need to have a mechanism to stitch in this environment. I think there are 2 approaches for end-to-end LSP, contiguous LSP versus per domain LSP, but I think we know that per domain LSP is better one with various reasons. And the setup with the per domain LSP setup is happening at the or in Bodo node, and need a mechanism to stitch the per domain LSPs. I think the motivation here is not to invent a new wheel, but I think last Chicago meeting, Julian presented stitching mechanism for a BRPC environment. So we'd like to use the same mechanism basically, but in a different context. BRPC is a peer-to-peer PCE, but here we have a hierarchy. So we would like to use the same stitching label definition that defined in Julian's draft. And this is also applicable for ACTN. We have a multi-LSP environment, how to stitch that. So basically, this is a high-level mechanism. If you have a two-domain, entry border node at the I+1 domain basically recommend the stitching label for the incoming inter-domain link identifier. And then it needs to propagate to the PCI I+1, and PCI I+1 will need to propagate that to the hierarchy, the top level parent PCE, and that parent PCE need to propagate that to PCE I, which is a previous domain, and then to the entry, the border node of the domain I, so that domain, the head node, it may have segment routing mechanism or RSPPT, include the stitch label recommended by the previous domain in its setup. Basically, that's the idea. The procedure here is basically the parent PCE request to initiate LSP. It basically computes domain sequence, optimal domain sequence, based on the customer request, and then figures out what would be the right sequence of domain. And then it contacts each domain, the PCE, as to what to do. And then basically in this diagram, we have a 3 LSP segment. So those need to be somehow stitched. That's the basic idea. So in this case, the parent PCE go recursive, backward first, talking to the last PCE domain of that end-to-end LSP, and then basically PCE propagates to the entry border node to assign stitching label. And then, as you see here, BN33 assigns stitching label 33, which is incoming label to that domain, and then it sends back to a parent PC with the RRO, SL33 and BN33 entrance, and then the last one, and then a parent PC get that information, and then parent PC propagates that to the previous PCE, and then talking to the border node, entry border node of that domain, BN41. So the ERO basically BN41 to BN42 and stitching label 33 and BN33 to complete that LSP segment. So, and child PC further propagates that to BN41, and then SL33 is encoded in the ERO in the RSPPTE and propagate to BN42, and then SL33 is a part of the label stack in case of segment routing. So you do kind of recursively all the way to the first domain, and we can have end-to-end stitching mechanism. So this doesn't require any new message type or any new encoding other than the Dujan draft that Julian is co-author with. And this is a key part of ACTN applicability to PCE. And we actually work with the other authors of similar draft. And so that's the last the point. Do you have any question? Yeah.
Julien Meric, contributor to the draft Dujan that you mentioned in your presentation. I'm glad to see that you consider that the idea we submitted in our draft got interest, and that you you want to consider it for your proposal. However, looking at my last slide from the presentation in Chicago, we mentioned the intent to cover the hierarchical PCE case within our work. So I wonder if I should take your draft here as a proposal to work all together, or as a counter proposal to fight against that idea for the future. So I just don't know exactly how we should consider that.
So, I mean, I'm open for any possibility. What is the best way to propagate consistent PCM mechanism, whether it's a BRPC or hierarchical PCE? So I would welcome that idea.
Yeah, the title of the draft was BRPC. The main idea there was about the stitching label on the code points allocated to that mechanism. So whether or not the scope had to be enlarged for the further work, we don't mind. But the way it's progressing there doesn't suit me as a contributor.
Yeah, but if the combined draft is BRPC, then I think we need to kind of rethink, right? Because it covers more than that. Is that you're willing to change the...
Updating the title is not an issue.
Okay, no problem. Yes, you are willing to work merging with the two. Okay.
Just clarification, when you traverse the third domain, the label you are pushing is not a cell, it's a binding seed. So you have a right
which one?
Reference.
Oh.
But the text is wrong.
I mean the reference? Oh, okay.
Yeah.
Okay. Okay.
Andrew Emmerich again. To add some more comments about Jeff's feedback. The V1 of our draft has been delayed also because we're looking at the ways to maybe merge with the binding label idea and propose something more generic to address all the related use case, binding, stitching, whether it is flat or hierarchical, whatever. So I think there are some common interests there, but we need to maybe limit the number of documents we are progressing in parallel.
Yes, I think we'll talk offline because I think, yeah. Okay.
Sure.
Just one comment, Yang. The intention of the draft is clear, but I think that you provide the example to explain the intention of the draft, but there is no explanation of the real procedure in the general. So I would suggest to make some description that is before the example to explain the real intention, because you list a lot of PCE mechanism and so on in the draft, but the real intention of the draft and in the context of all PCE story, it is not so clear.
Okay.
And then you start immediately with the example, but it's better to have a little section to describe the procedure and the intention.
Okay, yeah, that can be done.
So depending on the number of domains you're going to traverse, you're increasing number of labels on the stack. So you might think about the MSD and probably describe how you are going to use binding seed to expand. So if you cannot put number of labels needed to traverse and turn pass, you might need to do extension somewhere in between, or a priori you hit the egress from particular domain. We can discuss.
Yeah, I don't think I understand, so we can talk offline.
You may run out of labels.
Okay. Oh, you may run out of labels. Okay. Yeah, okay, we can talk offline. Okay.
Okay, so thanks, Young.
Okay.
Next presenter is Adrian.
I was having great fun. I was reviewing the experimental code points draft, and now you've woken me up. So I want to talk about this draft, which has been around for a while, timed out for a number of months, and then I came along to rescue it. What I've tried to do this time round is rewrite to inject a bit of excitement and passion, and update the process. The old process used to use specific messages, and I've changed that for no new messages. But the purpose and functionality is the same, which is when we use PCE to control or set up an LSP, we have currently no way of telling the head end of that LSP what the purpose of that LSP is. And that's kind of a hole. We've lived with this hole for a very long time, mainly because it used to be the head end that actually asked for the path, so the head end knew why it wanted an LSP. And then after that, we've lived with it sort of because an LSP from A to B, well, it's probably meant to take the traffic that's going to B. But when we set up parallel LSPs or tunnels in the network and things like that, we have currently no way of telling the head end what to use the LSP for. So this document addresses that. The intention is not to reinvent or not to invent new ways of describing the traffic that would go on an LSP, but to pick up an existing mechanism. And one such mechanism is defined for BGP called FlowSpec. But be very clear, this is not BGP FlowSpec. This is simply using the BGP encodings. We are not talking here about programming ASBRs for IP traffic flows. We're talking about telling LSP head ends how to behave. So the mechanism, firstly, capability advertisement. No point in telling the PCC what to do unless the PCC can understand. No point in asking a PCE to do something unless the PCE can do it. So normal capability exchange. Then we define a new PCEP object called the FlowSpec object, and you can pop 0, 1 or more of those on all of the usual suspect messages. And each object describes a traffic flow. So it describes a set of traffic that will go on the LSP you're dealing with. Inside the object is a single TLV. Now that sounds like really stupid. Why don't you go straight into describing the traffic flow with multiple TLVs? The answer is we wanted to break the TLV numbering space so that we could reuse the FlowSpec numbering. So we needed to put something in between, and so we've got this sort of container TLV. And so the sub-TLVs that can be in this, called flow specification TLVs, are a set of TLVs that when you combine them, describe the flow. For example, those might be destination prefix or source prefix. And when you add a number of them together, you describe the flow. So those TLVs come from a range 0 to 65535. Fortunately, BGP only uses the range 1 to 255. So we're able to carve out 1 to 255 and say, if you see one of those, go look at the BGP registry, and that's the type of flow descriptor we're using. But we've then got plenty more for ourselves to describe new flows that are not used by BGP. And an example of such a flow is for multicast traffic. So if we have a point-to-multipoint LSP, we want to describe that traffic. BGP doesn't care about that, so it doesn't have one. We've also added one for a VPN route distinguisher, which means that you can say traffic for a particular VPN will go down this LSP. So I did an example. We set up a new point-to-point LSP, and we want it to be for traffic for a couple of destination prefixes. So we would send a PCE initiate message saying, set up this LSP, and here's a flow spec object containing a flow filter TLV with two flow specification sub TLVs that describe the prefixes. Verifying the hex there is an exercise for the reader. It's probably wrong. What do we still need to do? We still need to push on with implementations. There are a couple of people on the fringe of implementing for prototype or moving towards product. We need to put some examples in the document because that will be really helpful. We need to look at whether we simplify or streamline the main use cases, possibly removing some of the BGP flow spec things, and a really sensible thing that was pointed out to me this week is during the capability negotiation, why not say which flow specs you support and which flow specs you don't support? This is something apparently that BGP implementations get really confused about, and it would be really neat just to say straight up front, this is all I support. And then we have to consider the other big thing that, again, hits BGP. When you have some overlapping descriptions of traffic, which one takes priority? How do I decide which LSP to put the traffic in if it fits, matches two different flow specs? It's not a new problem. We see it for BGP. We even see it for static routes when they get installed. And what we need to write down is clear, unambiguous rules, whatever we decide those should be. And then lastly, and the chairs can help with this, is this in scope for the working group? And if so, is it something the working group wants to work on, or should the proponents go away and sit in a hole?
So the reply to the last question then. So I think this is in scope. If we accept that LSP initiation's in scope, then this is just a corollary to that. So I think it's in scope. And since we all worked on LSP initiation, I assume we all want to work on this as well. Otherwise, we only have half a solution, right?
Well, I would agree with you, except we've got this far without needing. Now, I personally believe it's really dumb that we've got this far with people kind of cobbling things together with CLIs or netconf and PCEP. So I believe this needs solving, but we are where we are, and so that's why I asked the question.
Does anyone else have thoughts on that they want to contribute?
I think that's in scope and very much needed. We tried to abuse PCEP before. So I remember profiles. We had some vendor TLVs in recent drafts. So we need to do it. So question whether it's not too much, and specifically mixing data plane with control plane. I mean, maybe matching on RD is not such a great idea, but for the rest, I think it's very much needed.
Daniele, I agree with Jeff. And just one question. How often would this binding occur? Is it something that occurs often, or like configuration?
So I imagine that this depends. Okay, it depends on whether you're using your PCE in a fairly simple way, or whether your PCE is very aware of what the traffic matrix is on your network and is balancing traffic across LSPs and is totally managing the network. So,
okay, and then a non-political answer.
Reasonably?
Well, okay, I will retaliate by saying, what's the arrival rate of LSPs? These are unknown questions.
So practically today, the only way to get traffic into LSP is to resolve next hop, right? When your next hop resolve after tail end of the LSP, you'll send traffic over it. This gives you ability to not to, go into BGP configuration, start playing with next hop, which is the way of doing it today. So, the only way to do it more granular are per next hop in VPN.
Okay, thanks.
Next presenter is Drew again.
Hi. Hi. So this is the solution for PCE as a central controller. Next slide. So just a background. We have the architecture document, which is there in the TEAS working group. And this has done working group last call already. We have a use case document, which has been adopted a couple of IETF meetings ago and has been progressing well. And this is now in the PC working group, the various solutions meeting those as per the architecture and the use cases which are specified in the TEAS document. Next slide. So this is just the sort of like the document map that we have in the current PCE working group. The first document is talking in terms of a generic PCE-CC mechanism, mainly for per hop label download. And this also have the base mechanisms like what is the changes in the messages or objects, as well as the mechanism to synchronize labels when the session flap happens or session gets terminated and rejoined, and all the base features for PCCC. Then we have a SR document, which only talks about the changes needed to handle segment routing, SRT, LSP, and the label exchange label propagation mechanism for that. So for this, we need to add a new PCEP object, and that's what's been done in the SR document. Then we also have the sync draft, which talks about the various optimizations that we can do with respect to sync, similar to the LSP state synchronization. This is the label DB synchronization. Next slide. Okay, so in this slide, we describe what are the procedures involved, especially from the base document point of view. The description you will find in the architecture document as well as in the use case document. The idea is the LSP is being provisioned as an explicit label instruction on each hop based on the end-to-end path. So each router along the path will download the forwarding instruction and also reserve any resources as needed. And the mechanism to do that is via PCEP. So PCEP is a way to do that. And also the label space, we need to take care it. So the router would give some label space to PCE to allocate labels from, to make sure that there is no clash between a locally allocated label and the label which is allocated by the PCE on behalf of the router. So this is a very simple mechanism for how a PCCC LSP is established. Next slide. In case of segment routing, again, the description of the architecture and the use case you will find in the referenced section. The main change here is the SR label stack is still downloaded using the existing mechanism, that is the segment routing extension, which goes to the head node. And on the head node, you can give the label stack. This is more about how the labels are distributed. That is the SR labels, the adjacency label, the node label. Those are assigned via PCE and distributed via the PCEP protocol. So the idea here would be that we may not need to use the IGP mechanism, that is on every node allocation of a SID and node label, etc. All of this is done centrally by the PCE itself. And of course, that will have some benefits that you may not need to configure on every router. Things can be done in a SDN environment in a much more simpler way. So for this, we would need a label map, which is different from the download function that we had in the previous case, where you had an LSP. For the LSP on each hop, you were downloading labels. Here, you are assigning a label map to effect and assigning that for this node or for this adjacency, this is the label that you need to use. And this needs to be sent on all PSEP sessions so that all PCCs can see it. And also we need to handle how do we take care of redundant PCs and the label assigned by one PC is available and known to another PC. And again, the label synchronization mechanism should take care of that. Next slide. So the extensions that we have are basically the capability. The first, we need to make sure that we advertise this during open messages. For the base case, we have something like a label download, where the label is allocated by the PC, and via a new message, we call it the label update message, the information is downloaded on each node along the path. In case of segment routing, the labels are not allocated per LSP. They are allocated based on the topology. So for a node or a prefix or an adjacency, we assign a label, and then that label is notified on all the sessions, that is on all PCCs, to all PCCs, again using the label update message, but the mechanism is with a different object and other things. Then we also need to make sure that we handle the session termination process very, very clearly. So for this, the procedure is set that once a session goes down, all the labels that were received on a particular session are marked stale. And when the session comes back up again, we will try to synchronize again. A special process needs to be taken for the SR labels, because SR labels are not per LSP. So we need to make sure that there is another alternative PCE which can take ownership for those SR labels. So we have defined a procedure for that. And the label DB synchronization, the base synchronization is already defined, and the optimizations are further handled here. The label DB synchronization is little different from LSP DB, and that is also described in the next slide. Next slide, please. Okay, so this is the label DB synchronization procedure. So since the labels are allocated by PCE on that space, we need to make sure that how do we handle if there is a session flap or if a session goes down. So those procedures are basically listed down here. So this procedure is broken into two steps. The first, the PCE will, on session up, the PCE will try to, on session first, sorry, let me start again. So the first thing is that the PCC will mark all the labels received on this particular session as stale. And then when the session gets up again, the PCE will try to update all those labels. Any labels that is still marked stale will be reported back to PCE saying, these are the stale labels. What do you want me to do? What do you want me to do with them? And then the PCE can take suitable action. For SR label, which are not LSP related, because what is going to happen is that LSP DB synchronization will also take place. So LSP DB synchronization will also try to redelegate and assign the same labels or use different labels. So that process takes care of the labels for basic mode. But in case of SR mode, we would like the labels to be valid irrespective of which PC allocated them. So that procedure is also listed out in which a particular SR label control might be given to a different PCE. For this purpose, we have a label report message as well. So we have a label update and a label report messages described in this extension. Next slide. So here you are seeing the message. The idea is pretty, there are two types of these messages. The one is the label download and a label map. The label download is usually used for a per LSP basis. That's why it has the LSP object as a part of it. But for SR, we will not be doing it per LSP. In this case, we will use a new object called FEC, which identifies the node or a adjacency or a prefix for the SR label. Next slide. So as some of you would have seen this being presented in previous hackathons and previous bits and bytes, this implementation exists, but now since the PCC's document and T's have been adopted, and this now is the time for us to start making sure that the solution that we have, is it a good solution matching those architecture and use cases? And if there is any concerns and if there is any comments, we welcome them, and we would like to move this work through the working group channel and whatever are the comments that we get from the working group, so that we can handle them smoothly. Thank you.
Thanks, Dhruv. Any comments for Dhruv? So I guess I have chair hat off. This is John Hardwick. I guess I have a couple of comments for this. I haven't read the drafts, so my apologies for that. Tell me if I'm asking silly questions here. The first question is, I thought we had this idea that we could solve this problem by instantiating one-hop LSPs on each node in the network along the way. So I was kind of surprised to see these new PSEP messages.
Yeah.
Can you justify why we need the new ones, or why the one-hop LSPs did not fall out?
Yeah, so I also like the one-hop LSP mechanism quite well, and it worked very well for a basic per-hop LSP instantiation. But trying to put this for the SR became a little difficult, and because, as you know, that we don't have an LSP at that time, we are allocating a label mapping. So though we can retrofit it and try to make it work, it was just not very clean. So the implementation choice at that time, what we made was, let's have a new message and see how it goes. But we are completely open to the working group, and whatever working group feedback that we get, we will change it. And I know that my co-author Adrian is, I think I can see in the queue, he might have some opinion. So I'll give the floor to him.
Yeah, thanks. Well, maybe I won't talk.
It is kind of on, but it's a bit quiet.
You to talk.
Adrian Farrell. Yeah, so Dhruv and I exchanged email on this when I was actually paying attention, caused by him writing the slides. And I'm pretty much in the same camp as John, that I would like to make this possible, or as much as possible, use existing messages rather than new messages. So I think Dhruv and I will have a little huddle about this afterwards and see whether we can't at least collapse some of it into using existing messages.
Thanks. And it kind of brings me on to part two of what I was going to ask. So you mentioned that one of the rationales for having separate messages was to cope with the SR case, and I had a little concern with the SR case that we were sort of saying that we would bypass the IGP mechanisms for label distribution to the intermediate nodes. Yes. And if we're gonna do that, I think we really need to justify why we're going to do that. I think there's some bullet point on one of the slides saying that the centralized nature of PCE is better than the IGP for. Yeah, sorry, Dhruv, with dogs on my line. Yeah, so I think we need to justify that before we really build the protocol around that assertion, and that to me was a sticking point.
Okay, I think this discussion has taken place in the T's drafts as well, so I think we can relook the architecture and the use cases document. They do delve that yes, the IGP mechanism is valid and it's useful, but if PCE is also managing the label space, and as we know, via doing it IGP mechanism, the SR draft is become a little heavy with respect to the sRGB and other mechanisms and anycast and other things. So having a PCE mechanism to manage the label space has some advantages. So what we can do is in our document, try to make sure that we highlight that clearly, that why we are doing this.
So it's Adrian again, and I agree completely with the dog.
The old or the young one?
Yeah, the older one, the old dog is always right. And what he says to me in this case is that we have control plane mechanisms for doing everything that's in this document. And what this document is doing is saying, yeah, but there's also SDN, and maybe PCE is the SDN controller. So we're saying for LSPs, perhaps we don't need to use RSVPTE, we can touch the nodes. And for segment routing, we're saying, well, maybe we don't use the IGP, we touch the nodes. And there's BGP example of doing that out in the world. Now, whether that is the right thing to do or not is a wider question. But I'm not sure we want to have the debate on whether SDN is the right way to run a network. Maybe we do. How long have you got?
Not enough. Not long enough. Okay, thank you, Dhruv.
The last presenter is Young.
This is Young again. Actually, this is called PCEP-LS, PCEP link state. We have two individual drafts. One is for packet networks, and the other one is optical extension. Yeah, I think we need to understand where does this work fit. Actually, this is applicability. This fulfills the applicability of ACTN into PCE. I think stateful HPCE fulfills multi-domain coordination function of ACTN, as well as customer mapping translation function. And VN association, which is another draft, basically fulfills virtual service coordination function. And this PCEP-LS basically fulfills abstraction function with the support for abstract topology in both southbound and the northbound, which is known as MPI in the ACTN context. So this is the high-level applicability of PCEP-LS. As you see here, device report link state information using PCEP protocol to its child PCE, and then the child PCE send to the parent PCE this link state and T information. So it's a recursive structure which fits to ACTN architecture. And the idea here is that we only incrementally update and change. You don't have to wait the entire network OSPF-TE LSA to converge and then report the entire package. Anything happens in local link and node, we basically transport to the controller. So the controller would be having the up-to-date information rather than waiting for OSPF-TE to converge and then maybe BGP-LS package that using BGP-LS. So this is a very native PCEP mechanism for that. And we also support for abstraction. So key features of PCEP-LS, basically, we have a capability report for the link state and T information. locally and remotely. If you don't have a direct connectivity to a controller, it indicates that it coming from the remote. And also support for synchronization. And as I said, it's the most important thing is that this is very incremental update capabilities added so that we can benefit for fast conversions. And we also have a mechanism for backward compatibility. If we have IGP or BGPLS learned information, we indicate that where we learn that information from. And then we have an optical network extension as well for OTN and WSUN and FlexGrid. So this is very simple. We define one new link state report message where you can specify link state objects. We basically protocol ID and then flag and some other flag indicate remote or not. And LSID. LSID is basically a unique identifier of each node and link would be uniquely identified by a PCEP LSID, and it remains constant for the lifetime of PCEP session. And it can carry local and remote link state and T information. These are details of sub-TLB that we defined. And I think the most important thing is that last IETF, I think there was some decision was to be made, but it was put on hold. And then I'd like to add three implementation. We have hierarchical transport PCE controller, which is driven by Atri and KT. And then it was shown in the last hackathon and the Bits and Bytes in Seoul, Korea, actually, the previous IETF 97. And then we have another ONO-based controller, which is open source. Open source ACTN project, actually, we have a GitHub indicated over there. We implemented PCEP-LS on SBI as well as MBI. And another implementation, which we haven't documented in the current draft, is a CTTC. They implemented stateful PCE controller. They actually published a paper in ICTON conference, which just took place 2 weeks ago in Spain. And then they reported applying PCEP for FlexGrid networks using active stateful hierarchical PCE implementing PCEP-LS for abstraction mechanism. PCEP-LS completes ACTN applicability to PCE and stateful HPCE. We have, as I said, a number of implementations have been reported publicly, and then we actually handle comments from Ramon. We'd like to ask for decision because decision was suspended, but I'd like to make a decision for this work, which
Yes, my name is Bin from Atri, and so I like comment to the implementation report. Actually, we did the POC with the PCEP-LS, and we have 3 recovery schemes based on the SDN controller. We are very interested in the recovery time from the working past the protection path when the failure happen. I think that we find that PCEP-LS is very useful to reduce the response times when the failure happens. If you think about time-critical applications like recovery, I think that PCEP-LS should be a very useful solution.
Julien-Marie, Orange. We will agree that link state synchronization is a useful feature. All the more we already have IESA-STE, OSPF-TE, BGPLS, TE topology young modules, and I probably forget some of other things. So I still don't see the rationale to put that in yet another TCP-based protocol. All the more as you mentioned ONOS as a prototype there. ONOS and ODL already support various protocols, including some of the ones I mentioned before. So the feature is already there. So why would the routing area define yet another T synchronization support for that?
As I said, OSPF-TE or ISRC-TE, you have to wait for full convergence distributed using RSPF-TE. So as it's been indicated for mission critical recovery, you can't afford waiting for convergence. So this is improvement from existing IGPT mechanism. And BGPLS also use OSPF-TE mechanism and then package it using BGP transport. So, and I would say this one is actually proven in the experiment how quickly it can fix the problem to avoid the blocking. And so I kind of, ask for working group to respond because, you keep saying that we have other mechanism. Other mechanism is not same as this mechanism.
Well, maybe you can improve the others. If you want to add the...
You want to improve OSPF-TE or PCEP-TE? I mean, that's very obvious, right? Now we are shifting to more centralized. Yang is actually binary. I mean, it's not binary, okay? It's a text protocol. And we don't know how fast it can converge compared to binary. We have actually some experimental result that binary is much faster. So we can show it to you if you want, if you're interested.
I agree about binary, but we already have at least 3. One of them being BGPLS, also TCP based. So
but they don't support incremental update. You can update incrementally in BGPLS, but
if you want incremental, you can do IGPT.
Yeah, but would you rather work on OSPF-TE extension or PCEP extension to achieve the same thing? That's the question. It's a philosophical question. And then not many people now implementing GMPLS anymore. It's kind of fading away, unfortunately. Then what is your...
Let me disagree with that with my operator hat on. Operator hat on again. All optical equipment I'm aware of do support an IGP, at least for routing the management traffic. So adding more info in the IGP, which already is there, is pretty straightforward. Adding a new protocol because PCEP isn't deployed everywhere to support a feature that duplicates something that has been proven and existing over more than 15 years doesn't make much sense to me.
Yeah, I think that's your personal opinion. I hope that's not your working group had on it.
Yeah, so that's why I'm here.
Last time, Chicago, I think, if I remember correctly, I think Adrian is here, right? Still here. Thing is, make a decision. I'm asking for working group to decide, not, I don't want to convince with you because we disagree on some point, but I'd like working group at least have some, working group indication whether this is a useful thing or not. We have 3 implementation report, and it's already deployed. Why? What's the problem actually? If you have a OSPF-TE extension to do this and implementation, I would compromise, but we haven't heard such thing. We don't want to, change that. We'd rather change on this part.
So a few points. You don't need to wait for SPF to converge. At the moment there's an update, it will be distributed into BGPLS and go north. So it's sub-second.
And let me elaborate.
I'm not saying this work is not needed. So specifically for optical domain where BGPLS doesn't exist, it's very much needed. I still have my reservation in packet domain, specifically as it brings requirements to full mesh of PCEP session to every device.
No, it's not full PCEP session to every device. You can remotely learn. So you can have a direct attached node can report for remotely one.
You want to be fast, right?
Yeah, I mean, that's still fast. It's different issue with the convergence. Convergence takes a long time. And
so all of them are control planes, so I wouldn't call any of them fast.
I mean, that's a different issue. That's you're diluting some issue with some more fundamental issues. So that's not the issue we are talking about here, right?
So to rephrase, it's still needed, especially in optical domain. There's no alternative. In packet,
Correct.
if you have customers who are asking for it and find it valuable, then probably we should be doing it. We are IETF to follow. If not, IGP plus BGP provide pretty good solution. So maybe we should still be doing it, but having different focus.
Sure, at least the optical, I think we have a lot of more information than packet, and this proven very feasible for flex grid networks and so on. So, and PCE group also working on GMPLS, so at least we can, ask for that. Yeah.
Okay. Hamian from Huawei. I would like to add some simulation result because we have some kind of simulation on both PCAP-LRS and together with IETF young models running by NetConf or RESTConf protocol. So I think we tested only on topology discovery and reporting scenario and the convergence and simulate the convergence timing, and we find the gap between the two solutions is binary is about 2 or 3 times faster than a kind of text-based solution. So that's why we believe this mechanism and solution is quite necessary. And moreover, besides the optical demand on this kind of PSAP solutions because the lack of IGP, BGP on the transport side, there is still future upcoming demand from, say, microwave side. So it is also required to have this kind of generic PSAP LRS link state as a starting point for us to do some technology-specific extension. So currently what we can see already is we can see the future of optical extension and the microwave extension. But we firstly, I think the first milestone we need to achieve in this working group is to make sure that the link state, generic link state solution is adopted and complete. Thank you.
Jean-Marie, Orange again. I would like to hear some feedbacks from my fellow operators there, because if this specification is part of a vendor-specific black box, I don't care if it's standard or not, it's part of the black box. I really believe that whether it is packet or optical or something GMPLS can support, like microwave, we already have a common set of tools within the routing area, which are IGPTs on BGPLS. If we want to push the standard forward, those are the ways to go. If you want to turn your optical LS into BGPLS, you have a blessing.
And also, one comment for you is we have a lot of transport networks that doesn't implement ASUN GMPLS at all. And what are you going to do? This is the best bet, and that's why CTTC implemented PSAP for flex grid networks.
I'm not questioning the fact that it is possible. Of course, it is.
I mean, there is no other alternative.
I would like to see one optical networks that doesn't run an IGP, at least for the management traffic purpose. But I know plenty of them which don't run PSAP.
So my name is Michael Scharf. I've just heard that there is a performance benefit of TLB. To be honest, I mean, this is a parser issue. XML and JSON can be transmitted and parsed incredibly fast. And if there's a speed benefit, this is an implementation downside. So I don't see that TLB is anything to be considered here in that discussion.
Javier from Huawei again. I need to clarify a little bit because we, both the Yang and I, agree that there are existing similar approaches, but what we are proposing here is not to arguing the other is bad or something. Even we have simulation, we are saying the PSAP-LRS is something that should be coexist with our other solutions and complementary rather than competing with each other. We are not fully overlapping in the scope. That's our point.
Can we make this final comment, please?
I just wanted to rephrase my question. Are we a standard development organization or a catalog development organization?
Yeah, so I think, I ask you, because you're neutral here, as a co-chair, at least, ask working group whether, how does working group feel about this as a, consensus process, the procedure. We haven't done it, and we have a lot of interest. Implementers came and, reported.
So my thoughts on this, I'm trying to be as neutral as possible here. Both for this and the previous thing that Drew was saying, we have examples of occasions where we're using PCEP to distribute information which would traditionally be distributed by the IGP. So this moves PCEP, further away from the path computation provisioning side to be more in the distributed database game. And it seems to me to be a bigger step. And when I think about what we're chartered to do in this working group, it's not completely clear to me that we're chartered to do that kind of thing. So I think I need to have a conversation with our AD about the charter and the scope of this working group and whether we are even in principle allowed to adopt solutions which do the kind of job that you're asking. Now, it could be that it's not, and we need to recharter to take this on, or it could be that it is, and there's no draft. But I think that conversation needs to happen this week.
Okay. Can I have response for that? Do you think PCCC, which is adopted by TIS as an architecture, would that be original PC function you envision? It's not, right? Obviously.
No, but I think the charter was expanded to take on path computation and provisioning.
Label assignment as well?
Right, yeah.
Centralized?
Yeah.
But RSPPT has a decentralized label assignment procedure already.
Sure.
PCCC is overriding, so we are it's a changing world. And why not link state update using PCE?
Well, why not? That would be changing charter as well. So I think I have to answer that question before I can really adopt. But I mean, assuming we answer that, I'm interested in the room. Lou, you want to interrupt?
Lou Berger, speaking as TIS chair.
Yeah.
In TIS, we've been looking at basically SDN control of TE networks. And from my standpoint, I know the authors don't always agree with me. That's the really novel part of ACTN is it's SDN for TE networks, right? That's it.
Right.
We do have some discussion, we actually talked a little bit about this morning, where we're looking at PCE and PCEP as the way to go from the controller down to the network. Whatever the network may be. Maybe it's an element, maybe it's not. And so we've been acting with the presumption that moving PCEP towards an SDN control protocol was okay. That doesn't change anything you just said, where you got to make sure that it all lines up with your charter and your AD, but we sort of been assuming that you're going to go that way. Okay. So I read what is being asked for here is consistent with the TIS work on SDN control of TE networks. ACTN.
Okay. Thanks. So I'm just concerned to make sure we're not overreaching.
I think it's all good. As I said, it doesn't contradict it. I'm just saying that we've been going down a path with an assumption of where your group was going to go.
Yeah.
But it was our assumption. It's good for you to decide where your group's going.
And so the question for the room then, which I think we have to ask, who wants to see PCEP LS adopted in this working group? Raise hands. 4, 5, 6, 7, 8, 9. Okay, I count 9 hands. And who does not want to see PCEP LS adopted in this working group? Okay, I see 3 hands. Okay, so that's...
I think it would be interesting if, hearing from Julian, if he thinks that the notion of PCEP's use in an STN Control-T network is appropriate. Because I'm not sure if you're saying no to BGPLS because you don't like the specifics, or no because you want to keep the distributed model, the fully distributed control model.
I'm Julian Rick again. I mainly want to avoid duplication and overlaps between the protocols we have on the table. And this feature is already more than well covered by others.
So, having been building routing protocols for quite some time, there's a reason we built IGP, specifically BGP, able to cope with huge amount of changes at very high speed with large amount of information passed between nodes. PCEP is not really built for this frequency and this amount of information. So I think we need more semantics and more focus on parts of the network that are not as dynamic as really dynamic packet network. So again, going to optical to microwave, I'm for this because often this is the only protocol available in implementations. Looking at packet, I have my doubts. Again, if people want to implement it, maybe there's a rope to hang themselves, but I'm not convinced.
We're officially out of time here, so Adrian, we're on borrowed time if you want to make a quick comment.
Who am I borrowing from?
I don't know, whoever's going to come in and tell us to go.
I think we're at the end of the schedule. But
All right,
anyway,
yeah.
So we can go on till 9:30 tomorrow morning.
You can maybe.
So Adrian Farrell, it may help to flip this and look at what harm could it do rather than what benefit could it bring. And I think I hear Julien saying the harm would be competing protocols doing the same thing. And I might answer that with, yeah, but apart from burning a few people's IETF resources, is that actually going to damage anything, allowing the market to decide what it wants to deploy? And if somebody wants to waste their time implementing it, they might be right and onto a winner, or they might be wrong and lose whatever.
May I? Yeah. Just a short piece of answer to start with, Julian again. Operators at home, my experience of optical networks is that many implementations have been using the fact that there are too many competing solutions to agree on a common way to implement, thus preventing the interoperability, which is one of the main goals of the IETF. As a result, I still believe that the IETF should minimize the number of solutions there, not increase them.
We are just asking one simple TLV here, which is very implementation efficient. You know, there are many other PCEP solutions you saw today. There are many objects and TLVs. We are asking very simple change here, not major. So I don't know what, I understand your disagreement. I respectfully accept that, but I have different opinion. So what is your, you just ask people, what's your decision? I mean, make a decision, if either killed or continue on. You know, it's been a while, so we'd like to hear your consultation with the AD and then let us know. But you see the...
I need to come back to you. I think I see some strong support and strong opposition, so it's not a clear consensus either way right now. And
would it be easier for sending to the email list, because we have a lot of people not here?
Of course. I mean, this was not an adoption poll. This was just for my information. Right. The next step is I'm going to talk to Deborah about scope, and then we continue on the list. Thanks, Sean. Thank you, everybody. That's the end of our meeting, and we look forward to seeing you next time at IETF 100.